Alright, got the new evaporator installed. Got it full of glycol solution there. See, it's just hanging there. I used the old plastic posts there that held the original evaporator pan. So everything's mounted up. I put in about a 10% propylene glycol to water solution in there, something that should freeze at a lower temperature than the freezing point of water. That was a little difficult because I had some propylene glycol mixed up at about a 60-40 ratio. It was a bit strong, I'll admit, and then I had to figure out how to get a 10-90 there ratio. But anywho, she's been running for about 15 minutes with that solution in it. I ran it for a little bit just dry, and then I added it while it was running. We had pretty high head pressure there for a while, about 290, which corresponds to about 140 degrees, 139 on the high side. Then we got a little bit of wind here, and it dropped off. The compressor current dropped from about a little over an amp down to about 0.88 amps, and the wind died down a little bit, and it's on the rise again. Got a little bit of a charge in it, not sure what's the appropriate charge yet, but the superheat level is dropping there. This red line here down, you can't really see it all that well. The squiggly aquamarine color there, that's a thermocouple that's laid down in the bottom of the pan, just kind of near the stainless steel bottom of the pan, but away from the evaporator coil itself. Still adding a couple of degrees there on the heat interchanger. Usually maintaining about 20 or 25 degrees of subcooling there. It's a little warm yet today. It's about 80 degrees, but it's dropping, so I expect that pressure to continue to drop and that temperature to drop. With that high head pressure, we're maintaining about a little over 40 pounds on the low side, which is about 20 pounds higher than I was typically seeing with the plate heat exchanger, which is this one right here. There's just some 2 plates of aluminum with a copper serpentine clamped in between. There's no metallurgical bond in there. It was pretty effective at cooling the fridge, and pretty rapidly too, but the drawback was it cooled a little bit too rapidly. It would only run, you know, once the fridge was down to temp, it might run for about 20 minutes or so, maybe a half an hour at the most, which was barely enough time for the head pressure to rise to the point that the evaporator coil was properly being fed. So superheats remained high for a good portion of the run until it got towards the end. I have noticed that with that other plate heat exchanger and the more appropriate capillary tube sizing, I had about 96 degrees in here in the shop the last 2 days, and the fridge was maintaining. It was keeping the temperature down into the high 30s. Usually by about 4 o'clock in the afternoon, it might be running for an hour continuously, but it was pumping the heat out, and as soon as I opened the door up, it would quickly pull it down to 35 and shut down. So we're at about 0.99 amp right now. Air temperature in the bottom of the cabinet is about 68 degrees, so it's going to be a while until that liquid temperature drops and hopefully begins to solidify. So we'll come back in a few minutes. Okay, here we are about an hour into the run. I added a little bit of propane to the system here to try to get the superheat down a little bit, but been a gradual drop. We're down at saturation now. We've got 19 pounds right after the evaporator. Suction's at about 41 to 42, which corresponds to 20 to 21. So yeah, so we're right at about saturation right there. After the heat interchanger, we got about 40 degrees, about 20 degrees or so of added heat there from the heat interchanger. Box temperature, thermostat's reading about 58 near the top, not too far from the glycol tank. And in the bottom of the box, we're reading about 55, which is reasonable there. We're going to have a little bit lower temperature down there. As far as the actual glycol temperature itself, I do have that one thermocouple that's mounted, or excuse me, it's just kind of sitting in the bottom of the tank. It's jumping all over the place. It might be in contact with the stainless steel. I got some thermocouples that are coming in the mail. I'm probably going to do a rubber dip or something, and so I can do some liquid temperatures there and not have to worry about any kind of weird ass galvanic action with metals. But that seems to be kind of poking around in the 40s or so. Stuck my finger down in there, my fancy schmancy detector probe here, and it's starting to get a little slushy down there. The bottom layer, you know, 1/4 or 3/8 inch of the bottom of the pan is starting to freeze up. So system's going to continue to run until thermostat is satisfied there around 35. I don't know if we're going to start getting liquid back if it's overcharged at this point, considering that the temperature is still so high. So it's going to have to freeze a lot of that solution until the temperature gets down. So we'll keep you informed. Thanks. Alright, we're at about 2 hours and 20 minutes. Suction temperature is about 9 degrees. Saturation, pretty well close to saturation. Discharge pressures at 240 psi, which is 124 degrees. Our subcooling's at 104, so we got 20 degrees of subcooling there. Not too bad. We're running pretty hot on the high side there, but that's the nature of the static condenser. I could probably do a little better on that. The air temperature in the cabinet was about 51 degrees. I opened the cabinet to check the state of the glycol solution. Glycol solution is starting to freeze up towards the center there, where the capillary tube discharges into the evaporator, and then tapers out from there. I'd say about half, maybe a little more, maybe 60% of the mass of the liquid is frozen at this point. So what I'm hoping here is that you know, over the course of the night, that eventually the air temperature gets down to the point where the machine finally shuts down and satisfies the thermostat at 35 degrees, and then that frozen glycol solution maintains it for several hours. We'll see how that goes. The surface of the stainless steel steam table pan, it's got a little bit of frost on it, and then the fins have a little bit of tiny, you know, not even really any frost at all. They seem to be absorbing the heat and trying to transfer it into the sheet metal pan. So and then the temperature right after the heat interchanger there is maintained at just a few degrees above saturation. So we should be getting pretty close to isentropic compression, but I don't have a pressure enthalpy chart in front of me. I haven't looked at that yet. But temperature inside the shed here is dropping, so our discharge temperature is down to about 160 right now. Not doing too shabby. So just gonna wait and see. Thanks. Alright, so the night has passed. I just got up here and came out to the shop to check the status of my refrigerator. Very excited, like Christmas morning. Wanted to see how well that frozen glycol tank held everything. Before I went to bed last night, I threw my finger in there, and boy, that solution just froze up nice and hard. Something I'm not used to seeing with a glycol solution. Usually it's a little slushy, but it pulled the whole thing down and froze it. So it was probably getting into the low 40s, mid 40s whenever I went to bed last night. As it appears right now, the machine shut off at about 10 after 12, and here it is 7:17 in the morning, and it still hasn't come back on. So it held for more than 7 hours. So I'm pretty satisfied with that right now. We're at 39 degrees. It would have dropped until it met the thermostat, which was set at 35. That thermostat is it was set from 35 to 44, which is where I had it from the old plate heat exchanger. The reason the range was so large is I was trying to prevent short cycling, because it would only take about maybe 20 minutes, 25 minutes for it to satisfy that. So so that I didn't have to deal with, like I said, short cycling. Because I got an air temperature in the cabinet right now of about 39, the thermocouple in the bottom of the cabinet is reading about 38. So we don't have much gradient there and much stratification in air, which is interesting to me. So I went ahead and I adjusted the thermostat. We're going to run at 34 to 40. We're going to let it pull down a little bit colder than the next cycle, and of course it's going to kick on a little bit sooner at 40. So I don't want to open up the air or the door yet because the thermocouple probe for the thermostat is just dangling in the air there, and I know that when I do that, it's just going to kick the machine right on, and it's really not appropriate for what the cycle requires. So in a rather short time here, probably sometime today, I'm going to end up rubber dipping the thermocouple for the thermostat probe, or wrapping it in tape or some substance, and I think I'll try to bond it somehow, mount it, clamp it to one of the fins on the pan there. I think that'll help matters a bit, and with the added thermal mass, it should help prevent that cycling, that quick cycling whenever the door opens up, which is unnecessary, like I said. I'm really curious to know what the state of the glycol solution is right now, but as I said, I don't really want to open up the door and start probing around because that's going to kind of screw things up. Today's Sunday. I'm going to go get some brunch here in a little bit, and so I think I'm just going to spend the day, you know, reading and just keeping an eye on this thing and keeping my fingers out of the fridge. So that'll have to do for this video, and I'm sure there's going to be some updates here to see how it progresses. But just to summarize a little bit, R290 fridge with that 10% propylene glycol to water mix. There's about 1 gallon in there, so about roughly 8 pounds. And it took about 6 hours for it to pull the temperature of the whole box down and freeze that whole solution. So it took about 6 hours to pull down, and it's been off for 7 hours. And I'm going to expect this thing to continue to be off for probably another hour or so until it reaches the set point of 40 degrees. Something else to consider too is last night it was about 80 some degrees in here, 80 to 90 degrees in the shop while it was doing that pull down. Maybe in the high 70s towards the end of the pull down. Right now it's about 59, something like that, about 59 degrees. So I wish I had more temperature control in the ambient environment, but it's what I have to deal with, so just have to work with it. Thanks.